Hello, pre-callers. Back for a little bit more with vectors. We're going to do applications of vectors. It's not too much. It's not too hard. Now, in this first one, I'm going to go into more detail so you really understand what's going on. But when you have, so twins Mo and Joe are pulling a wagon down the street. Mo's pulling with 28 pounds of force at a 28-degree angle. So that would look something like, say, this, okay? That might be Mo. And then Joe's pulling with 36 pounds of force at 43, so a little higher and more force, so it might look something like this. Well, you can imagine if there's an object here, where it's going to go is really somewhere in the middle. And what you really do is you do vector addition. So if I were going to move this top one over, which is Joe, and do head to tail, it would look like this. And notice that the resultant is going to end right where that did. So the purple is what's really happening, but if I slide Joe over to the orange and do it as head to tail, it's really just vector addition. So basically all these are vector addition, okay? So we don't have to make this harder than it is, especially given the situation we're in. So we're gonna go vector Mo is 28 cosine 28, because I gave it to you in terms of magnitude and direction. Cosine is always the x-coordinate. And then for the y-coordinate, it's always sine. So you would do 28 sine, 28. That's for Mo. Now we'll do Joe. And Joe is 36 cosine 43. And then 36 sine 43. Okay? Then basically all you're going to do is pick up your calculator. And what you can do is type all of this in. You're going to add vertically. So you would type all this in as a plus. Okay. I'll go ahead and show you on Desmos right now. So I'll go back to here and go to Desmos. Okay. And so it was, I want to make sure that I'm in degrees, which is under tools. So let's check. Oh, nope. It's in radians. So I'm going to go to degrees. Okay, and then I'm going to go 28 function cosine 28 plus, I want to make sure that I end my parentheses. So I'm going to hit the end of my parentheses and now hit my plus. And the other one was 36, hit function and go to cosine 43. Okay, so see how I'm adding those? I added the x coordinates. X's always have the cosine. So 28 was the pounds and 28 was also the direction. 36 was the magnitude or pounds and 43 was the direction. So I've got 51.051. So I go back here and this becomes 51.051. And now I do the same thing with sine. So I'm going to go back to Desmos. And maybe I can just change these to sine. What do you think? Yeah, look at that. Sine. We got to make sure we change both of them to sine. And we don't want these extra parentheses. Those are making me a little bit nervous. I want to make sure that I'm not, that's not what I want. You don't want all these parentheses. They have to match up properly. So we get 37.70. Okay, so that'll be 37.70. So, whoops, I'm so sorry. So all I want to do now, it says, what is the resultant direction and magnitude? Okay, so now I want to use my information. So I added those up. So for the magnitude of the resultant, so the magnitude of the resultant is the square root of 51.051 squared plus 37.70 squared. And I'm just going to type that into my normal calculator, however you guys want to type it in. So I'm just over here typing it on my Casio. So it's 51.051 squared plus 37.70 squared. And we got approximately 63.46 pounds of force. Now notice it's a lot more than those two, so that's good. Now theta is always tan inverse, and then you put the y, 37.7, over the x, 51.05. And so I'm just going to use my calculator. I'm using my Casio. I'm just typing it in over on the side here. And I'm going to go tan inverse and then hit my fraction key. 37.7 over 51.05. Okay. And so we get theta is 36.45 degrees. And again, that makes sense. That's a little bit between them. A lot closer to Joe because he was pulling at 43. Well, it's kind of in between them. It's between 43 and 28. Okay, so you don't have to draw the picture. You can just always do set them up, add them, and do Pythagorean theorem and tan inverse. It's all you have to do with those things. Okay, so we don't have to draw it if we don't want to. All right, so let's try an object. Is acted on by two forces, 52 pounds with 100-degree angle between them. Okay, so this one, we do have to picture what's happening, because if this is going straight on that, and then this one is 100 pounds, that's 100 degrees between them. So what you want to do is put one of them at 0 and then one of them at 100. So we'll pick the first one, 52 cosine 0, and you just write it out as 0 because you're putting it on the x-axis. And then 52 sine 0, and then the next one we do 75 cosine, and we use the angle between them because that's 100. And then 75 sine 100. And you just pick up your Casio. Remember, you're adding these two together, and then you're adding these two together, okay? So 52, I'm typing this in, cosine 0, I'm in degrees, plus 75 cosine 100, and I'm getting 38.98. And then I'm just going to go up here and change those two cosine words to sine. So I just change it to sine, make sure I'm in degrees, and I get 73.86. Now I need to do the last, that was just the first three steps. I added them up. I set it up, step 1, each of them, step 2, add them, step 3. Now I need to do my magnitude of the resultant, which is the square root of 38.98 squared plus 73.86 squared. So you're going to type that in, 38.98 squared, type it in all at once, 73.86 squared, okay? And that gives me a magnitude of 83.51, okay, and that's going to be pounds. And then I'm going to do tan inverse, y over x, 73.86 over 38.98. And I just hit tan inverse, fraction, 73.86 over 38.98. And I get theta equals 62.18 degrees. Okay, and that would make sense because 62 degrees would be somewhere in the middle of this. Okay, so it'd be somewhere in the middle of that. Sorry about the phone. Okay, all right, example 3. So we just set them up. A plane flies due west at a speed of 110. Now, due west, I'm going to have to figure this out. Okay, due west, if this is east, west would be right here, so that's going to be 180 degrees. So that's going to be 310 cosine 180 for the plane, 310 sine 180, okay? There's wind blowing, so 25 miles at 13 degrees. So that's going to be 25 is your magnitude, cosine, your angle is 13, and then 25 sine 13. Just going to add them up. So you type in 310 cosine 180. You type it in exactly like it's given. Remember, you're typing these, adding them up, and then you're adding up these, okay? So 310 cosine 180 plus 25 cosine 13. You're going to get an approximate number, and you're going to get approximately negative 285.6 or 0.64. Okay, now I know the x is negative, so I'm going to have to star that and add 180 to my angle when I get there. Okay, change the two words cosine to sine. So delete sine, and I get 5.62. Okay, now I'm going to do the magnitude. So that's the speed of the plane, the result. So the plane's going, but the wind is pushing it off course just a little bit. So I do 285.64 squared plus 5.62 squared. I don't worry about the negative because it would always go away. Square root of 285.64 squared plus 5.62 squared. Okay, and that's approximately 285.70 miles per hour. It was set at 310, but the wind is slowing it down, okay? And then theta is the angle that it goes. Instead of going directly due west, it's being blown by the wind. So we're going to see what happens. Theta is going to be tan inverse of 5.62 over negative 2.8564. You have to put the negative, and then we're going to have to add 180. So we're going to hit 5.62 over negative 285.64. And I get that theta is negative 1.12 or 13, but I'm going to go plus 180. Okay, so theta is 178.87 degrees, which makes complete sense because it was going due west, but the wind blew it up just slightly north of due west. So there's your two final answers, okay? Example 4, same thing. We're just going to set them up, add them, Pythagorean theorem, tan inverse, okay? So they hit at the same time, 66 newtons, that's another measure of force that you use in physics, 50 degrees, so you just set it up, force 1, that's a physics notation, 66 cosine 50, and 66 sine 50, and then force 2 is going to be 88 cosine 70 and 88 sine 70. And we're going to just punch that in our calculator. 66 cosine 50 plus 88 cosine 70. We're adding, going down, and we get 72.52. Change both the words to sine for the y value. Sine is always y. And we get 133.25. And then we're going to do the magnitude of the resultant. It's going to be Pythagorean theorem. Okay, so square root of 72.52 squared plus 133.25 squared is, so 151.71, and that is newtons, okay? And that's how many newtons it has. And then we're going to go and do tan inverse of 133.25 over 72.52. So tan inverse fraction 133.25 over 72.52. And we get theta is 61.44 degrees. And that is all we have to do each time. Same process, okay? Last one. Oh, Mr. Watkins and I are fighting. Uh-oh, pre-cal books are so awesome. All right, so here we go. We're fighting. I'm pulling, so Deloach is pulling with 46 pounds of force. And the angle between us is 58. So what we have to picture is Deloach here at 46 pounds. We'll put Deloach here. And what am I pulling? Okay, 46. Stronger than him, of course. So I'm going to put me at 0. 46 sine 0. And then Watkins, there's a 40-degree angle between us. So we're going to put Watkins here. Okay, 40 degrees between us. Okay, and he's pulling with, 58 degrees between us. Sorry, 58 degrees between us. And he's pulling with 40 pounds of force. So 58 for him. And you could switch around who was on the 0, okay? The book, as you know, is going to go something like that, between us. So we add them up, 46 cosine 0 plus 40 cosine 58. And we get 67.1, let's make that 20. And then we just change those words to sine. And we get 33.92. Now we're going to do our Pythagorean theorem. Magnitude of the resultant, 67.20 squared plus 33.92 squared. So square root 67.2 squared plus 33.92 squared. And we get 75.28 pounds of force. And then theta is going to be tan inverse 33.92 divided by 67.20. Always do y over x. So tan inverse fraction 33.92 divided by 67.2. And we get theta is 26.78 degrees. And I'm going to put away from Deloach. So we know that that's the angle going, so that's this angle right here that's coming away from me towards Watkins, because it's not equal on both sides. So I'm just going to clarify that that's away from Deloach, and there's the force.